what got you interested in meteorology and atmospheric science?
So growing up, I was really interested in maths, and I was also something of a surfer. And so surfing, you're worried about where the winds are and so on. Maths I just was doing because it was fun, and I didn't want to be a maths teacher, and I didn't know what I should do. So in my second year of university, I took PDEs and I took fluid mechanics, and I loved them both. And then those two professors said, we're going to have a camp out weekend and we're going to show you how to use these equations to understand the atmosphere. And the camp out weekend was fantastic, and we did all kinds of cool things. We used the thickness equation to measure the height of a hill, and it changed over the weekend, so we learned about error in observations and all that sort of stuff. And that was it, I was hooked.
So now that you are here at Penn State, what is a current main active area of your research?
So my research focuses on tropical cyclones, and I like to say soup to nuts, because I think about how they're formed off West Africa, or how they're formed in the subtropics in a completely different way. And I think about how they evolve and how we call it extratropical transition, where a tropical cyclone becomes like Hurricane Sandy. So it changes structure, becomes much larger, moves much faster. And forecasting that is a real problem. So one of my areas of research is to think about how we can understand these storms better from what we call ensemble forecasts. So this is when you take the same computer model and you change it very slightly, and you make 10, 20, 50 forecasts of the same day. And we can look at those forecasts and use advanced statistics. So we're collaborating, my grad students here and I are collaborating with colleagues in the Department of Statistics, and we're using new statistical methods to take those ensemble forecasts. And you could get 50 forecasts a forecaster gets, and they're told in an hour you need to have a forecast. And what our method does is, in a short amount of time, says those 50 forecasts really boil down to 4 or 5 physical situations. And that then gives the forecaster a very finite amount of information, which, combined with their experience, turns into them being able to make a more effective forecast.
What kind of impacts can your research have on society? Obviously, with it dealing with tropical cyclones, those affect people. So how does your research look to?
We can also improve our understanding of these storms, and that will let us look at different climate regimes, and that's something I'm going to start working on in the next year, because how do these things change if the underlying climate changes? And that could be important. Like at the moment, the northeast US is undergoing changes in the infrastructure motivated by the damage caused by Hurricane Sandy. Well, infrastructure is a 30 to 50 year investment. And so if we have evidence that over that period something's going to change in terms of the atmosphere, then again, that's better than having no information. And so we can say there's a high probability there'll be more of these, less of these, whatever. That lets us plan for the future. What motivates me is the impact on people, and it's also what motivates my students. I think one of the best things about working with students is they want to change the world.